Hello everyone. In this video, we are going to discuss about composition of function. Composition. In your previous grade level, we already discussed about combination, how to combine two functions by either of the four mathematical operation, like plus, minus, multiplication, or division of functions. It is your previous level. For example, if you have a function f of x, which is equal to, like you can take any function, f of x is equal to 2x plus 3, let me say, another function g of x, which is x minus 1. If you are given how to add these functions, like f plus g means, like collecting and adding the like term. 2x plus x would be 3x, and 3 minus 1 would be just 2. This is a way how to add. Take the difference, minusing also the same, and multiplying means, it's distributing. So that's not new lesson for you, but as a revision, okay, the textbook puts for you here, just to recall and to remember. Our today's main lesson is how to compose two functions. Before that, let's take correction on our previous homework. In our previous homework, question number 2, for each of the following function, give the set B, for which the function f from real number to b become onto. That means we are asked to find the range of each function, like the appropriate range. If we mention the appropriate range, that means the function is going to be onto. Okay, ontoness will be expressed like focus on the range. So to make it onto, what is the appropriate range? So the first one, A, says f of x is equal to x squared plus 2. This is a quadratic function. And the graph of this function will be, it's an upward parabola, but the vertex will be at 2. It will be bent up. Okay, it's a parabola upward because the coefficient is positive, but where is the vertex? We need to move it 2 units up because there is plus 2. That is vertical shifting directly. If it is plus 2, you have to move 2 units up. If it's minus 2, you need to move 2 units down. So what is the range here? The range is y greater or equal to 2 because the graph is completely above the number 2. Y greater or equal to means the range will be from 2 to infinity. Above 2, any number. So the appropriate range, or the b, must be from 2 to infinity to make it onto. That is answer for A. B, it's absolute value of x plus 5. Again, absolute value of x, the graph of absolute value of x, if you remember previously we draw it, it is just v. The vertex will be at origin. The same manner, absolute value of x plus 5, it is v, but the vertex will be moved 5 units up because plus 5 is there. If you substitute 0 here in place of x, if you insert 0, 0 plus 5 will be 5. So the graph completely stays above 5. So the range will be y greater or equal to 0, or we can say from 5 to infinity. No, y greater or equal to 5, or it will be from 5 to infinity, inclusive at 5. That's closed interval. And the next one, f of x is equal to 3x. Absolute value of x, or absolute value of 2x, or absolute value of 3 outside x, any number, it can be outside there. Okay, if the number positive, the graph will be still v, but the coefficient number here, it increase means the graph is getting narrower and narrower, and it will be near to the y-axis. So this time, absolute value of 3x, when we say, it is the same. It's like v, the vertex will be the same origin. So we can draw the graph, or we can consider the graph. Graphically, it would be better to observe the range. The graph will be just v and an upward because it's positive. If it's negative, it's going to be downward. Therefore, what is the range here? Y greater or equal to 0, or I can say from 0 to infinity. That is a range, and that must be the b value to make it onto. And the last one, D, the graph again here, it says 1 minus 3x. It has to be downward because the coefficient of the absolute value is negative. But where is the vertex? If you insert 0 here in place of x, if you insert 0 in place of x, it will be 1 minus 0, which is 1. So you have to bend it at 1, and the graph will be downward. Why it's downward? Because the coefficient of the absolute value, as you see here, it is negative. Therefore, the graph will be downward, means the vertex, the range will be, or the graph will be totally below the number 1. So y must be less or equal to 1, or we can say from negative infinity until negative 1, positive 1. We need to close interval positive 1. That's going to be the range. That is negative infinity. Okay. Okay, so these are the answers for question number 2. When you go to question number 3, what does it say? Show whether each of the following function is one-to-one correspondence. What does that mean, one-to-one correspondence? To check one-to-one correspondence, we have to check first one-to-oneness and then on-to-ness. Is the given function one-to-one or on-to? Like if it can satisfy both conditions, we can say it is one-to-one correspondence. The first one, A, as you see here, the function, it is linear function. Always remember, linear functions, always they are one-to-one and on-to. Okay, that in their domain. Their domain is a real number and the range also real number. Because linear functions, they are like a straight line. Straight line, either slant to the right or slant to the left, it depends on their slope. But as you see here, the slope is positive. So the slope here, it is 3/5. Anyways, it is a line, a straight line, so it can be crossed once only by horizontal line test. You can check. Therefore, it's linear functions always without any precondition. Linear functions are one-to-one and on-to. So we can say the first function is one-to-one correspondence. This is one-to-one correspondence. Okay. What about B? B, as you see, the function is the square root of x, radical x. Radical x, the domain must be x greater or equal to 0, because we cannot take as an input negative numbers here. Square root in the radical, we can't take negative numbers. So the domain, it's appropriate, it's mentioned well. And the graph, how does it look, the graph of this function? Square root function, it's a concave down graph, and the vertex will be origin. Okay, it has only one wing. It's not fully parabola, horizontal parabola, you know, it's not fully. The down part will be omitted because just this one is only the positive part. If it's negative here coefficient, it will be the down part. But this time it's just only positive one. So we'll consider only the upper part. So this graph, when you see it, is it going to be crossed by horizontal lines more than once? No. So it's one-to-one. At the same time, on-to-ness, what is the range of this function? The range, as you see, the graph is completely above the x-axis. So y must be greater or equal to 0, or from 0 to infinity. Does this range mentioned here? Yes. Okay, that is a formal range of the given function. Square root of x, the range, as you see, because the graph, as I told you now, the graph will be like, it's a kind of this one. It will be when, in case of power function, we have seen it. In case of power function, x to the power of 1/2, x to the power of 1/4, or 1/6, the graph is similar. They will be started from origin and then they will be bent down. So the domain, it is x greater or equal to 0, and the range also x greater or equal to 0. So that appropriate domain is already mentioned here. So on-to-ness works here because the range is the formal range, or the appropriate range is mentioned like y greater or equal to 0. Range, when we are talking about range, we are talking about y. So y must be greater or equal to 0. And one-to-oneness we can check by horizontal like this, considering the graph. It will be crossed just once. So it is both one-to-one and on-to. So we can conclude, or we can deduce it is one-to-one correspondence, the second function also. So here we can say it's one-to-one correspondence. Okay, let's continue the next one. C, the function is 5 to the power of x. What number can be inserted in place of x? Any number, positive, negative numbers, it's okay. In case of exponential function, any number can be inserted here. It will never be undefined. Whatever the number you insert is as an exponent, it can't be undefined. If you insert 0, for example, 5 the power of 0 is 1. So the domain is real number, obvious. What about the range? 5 the power of x, you cannot make it 0 or you cannot make it negative, the whole outcome, whatever the number you insert here. So that the range must be from 0 to infinity, but not including 0. We can't make it 0. That's why open interval I put here. So the appropriate range is already mentioned. If you remember the graph from your previous grade level, the graph of this function 5 to the power of x is, it's a curve, okay, passing through the point 0, 1, and upright and down left, but it will never cross the x-axis here. That means the negative x-axis will be the horizontal asymptote. This was the graph, grade 10 lesson. So that, is it one-to-one? Graphically, if you observe, yes, it will be crossed just once. What about the range? The range, as you see, since the graph is completely above the x-axis, as you say, and it doesn't touch the x-axis at the same time, so the range is 0 to infinity. So it is onto, by observing the range, it's onto, and graphically by horizontal line test, it's one-to-one, so that it is one-to-one correspondence. So that is the answer for C. This is all the homework that I gave you. One question left. That is our previous homework. Don't forget that. One question left. The last question, it says f of x is equal to, it's quadratic. Again, for this quadratic, remember the vertex. Where is the vertex? Vertically, +1 it says here. This is vertical shifting. If the quadratic equation is given to you in the form ax minus c the whole square plus d4, okay, the d means the vertical shifting directly. If it is positive number, you have to move vertically up. If it's negative number, down. The c you need horizontally, but in opposite direction we need to move. That is the rule if you remember. Otherwise, since it's quadratic function, they are a parabola. So the domain is a real number and the range, it depends on the vertex. But here the domain and the range are specified. We have to check that. So remember the graph. Anyways, where is the graph? Where is the vertex? I mean, +1. We have to move 1 unit up. And here -1 there means, if it is minus, this time in case of bracket, okay, the one which is a square. If it is -1, you have to go 1 unit to the right. If this number plus, you need to move 1 unit to the left, like in opposite direction, because it is in the square. The rule says the number which will be squared with x, like horizontally you have to move, but in opposite direction. But the outer number which will be taken here or written here, it will be directly. If it is positive, you need to move up. If it's negative, you need to move down. So 1, 1. Vertically, 1 unit I have to move up, and horizontally, 1 unit to the left, to the right I have to move. Then the vertex will be here, and the parabola will be upward. This is a graph. The graph of this function is upward parabola. But what is the domain here? From 1 to infinity means I have to remove this part. Finished. This is a graph. Only this part will be considered. Is this function 1 to 1? Yes. By horizontal line test, it will be crossed just once. What about ontoness? Ontoness, we have to consider the domain. What is the range? The range is the graph completely above 1. That means y must be greater or equal to 1. Is that range mentioned here? No. As you see, the range here mentioned is 0 to infinity. But it was supposed to be from 1 to infinity. From 1 to infinity. Why? Because as you see, the graph completely stayed above the number 1 on the y-axis. So therefore, the appropriate range is not mentioned, so it is not onto. If it is not onto, we can say it's one-to-one correspondence, so it is not one-to-one correspondence. So that is the answer for the homework that I gave you. Let's continue to the today's lesson, that is composition. What means composition? Let's see the definition. It is a function f from a to b and a function g from b to c. Let's say there are two functions b, f and g. The f is from a to b and the g is from b to c. It's said to be, let's say they are functions. So the composition g by f denoted by GOF. GOF means the composition of g by f. It is the same as GOF x. GOF x is the same as g of f of x. So g of f of x means it is the same as g of f of x. Let us see by simpler example, and then we'll go to the process form. Okay, here it is by diagram. It is given the Venn diagram. The function f, the combination, look, observe, a combined with 1 and the b combined with 1 again. It's okay. The a cannot combine with two different outcomes. Okay, any domain cannot move out to two different places. That's the restriction of function. But two different domains, they can have same range. It's okay. A goes to 1 and the b goes to 1 again. C goes to 2, and as you see, d goes to 3. This is the function f. And the function g, 1 combined with e, and 2 combined with f, and 3 combined with h. The function g is not onto because there is one range which is not combined. Okay. But our lesson this time, it's not one-to-oneness and ontoness. Then we are asked what? G of f of a. G of f of a. This is the meaning, because according to this definition, gov means g of f of. You have to make it. If it says gov x, g of f of x, you have to make it. So the same pattern when you go gov a, g of f of. This means g of f of a. That is the meaning. So what's f of a first? You have to think of that. F of a means when you insert a in place of f, what is the outcome of it? Like when you substitute a in place of f, what is the outcome? This is outcome. The outcome is what? It's just 1. So it's going to be g of 1 remains. Because this one I replaced by 1. Why? Because it says g of f of a. So first of all, I try to think of f of a. I composed it. And what is g of f of a? F of a means it's 1. Okay, then the next one, g of 1. What is g of 1? When you input as 1, okay, when you take as an input 1 in place of g, what will be the output? The output will be e. So the answer will be e. The second one, go of d, it says. This is the same as g of f of d, which is g of, what is f of d? Let's read from the table. F of d means when you insert, when you input, when you take as an input d for f, what is the output? 3. Okay, this one done in the inner part. Now g of 3. When you input, when you take as an input 3 for g, what is the output? That's h. Final answer will be h. So the answer for b is h. The answer for a is e. How comes? By input process. You can see the answer. The process. Shortly, g of a means g of f of a. What's f of a? It's 1. And what's g of 1? When you take 1, it's going to be e. And that's the second answer also. Here it is. You can cross check. This one, diagram, way easier. The second also the same. F and g given, and then a it's asking g of b. That means g of f of b. That means g of what's f of b. When you take b, it's 1. Okay, again g of 1, again it's e. Done. The next one, g of c. That means g of f of c again. That means g of what's f of c. When you take as an input c, what will be the output? Is 2. G of 2 is what? G of 2 now. After that, g of 2. When you take as an input 2, the output will be, it is g. So the answer will be g. So this answer also written shortly. These are Venn diagram way. What about functional form? Here, as you see, two functions given. F of x is equal to x plus 1. And g of x is equal to x cubed. These two functions are given. And then what is asked? Fog x, that means f of g of x, and then g of x. Let's do one by one. First one, a, fog x. This is it. This means f of g of x. F of g of x, because what comes at last? G. So g of x will be inner now. This is the same as f of, what is g of x? Bring it. That's x cubed. It's already given. Now we need to think of f of x cubed. Look, in place of g of x, I substitute x cubed because it's given. Now I need to think of f of x cubed. First of all, everyone try to observe. What's f of x? F of x is 2x plus 1. What will be f of y? F of y will be 2y plus 1. What will be f of z? F of z means 2z plus 1. Like when this change here. X, x, y, y. And the z, z. The other the same. The 2 there, the 1 there. The 2 everywhere there. So when I say 2x, I mean f of x cubed, I have to replace x cubed in place of the first. The other the same. 2 times x cubed plus 1. You see, x cubed will be replaced in place of x cubed. Because f of x means 2x plus 1. So when you say f of x cubed will be substituted in place of x, in place of the variable. So that is the answer for A. This one is somehow a different process, not like the Venn diagram. And this is mostly asked in applicable way. Okay, We can proceed to the next one, B. Not B actually, the continuation of the second. I can say it B. It says GOF, G of f of x. This is the same as G of f of x, which is G of what is f of x? 2x plus 1. Okay, now remember, what is G of x? G of x means x cubed. What if it is G of y? It will be y cubed. Anything you input in for G, it will cube it, because it's given to you. G of x means x cubed, like it will cube only. The f, it will multiply by 2, then add 1. Whatever you take as an input. So here, the G input is 2x plus 1. So what to do? Cube it, because the rule says G of x, rule says cube it. Like when I say G of y, y cube. If I say G of z, it will be z cube. So anything you take as an input, it will be cubed for G. So that G of 2x plus 1 means the 2x plus 1 will be cubed. So that's going to be the answer. So this is the third example for us. We are composing function. Okay, let's go to the next example. Okay, the next example again, here it says f of x is equal to the power of x, and g of x is equal to square root of x. Their domain and range given to you. Exponential functions, the domain real number and the range obvious. Appropriate domain is given to you. Then what is asked? Find g of x and the domain also. First of all, let's find g of x. This is the same as g of f of x, which is g of what is f of x? To the power of x, which is g of what? To the power. First of all, g of x means, again, as I was mentioning before, g of x is square root of x. If I say g of y, square root of y. If I say g of z, square root of z. What the g do? Like putting in the square root everything. So it will be square root of to the power of x. Now what is the domain of this function? The domain of this function, you need to start like square root of to the power of x. To know the domain, whatever it is, whatever the number you insert, it has to be greater or equal to 0. The reason, because square root function cannot be negative. That is the starting point. Square it both sides to remove the square root and get the value of x. The x is the domain, remember. The domain means the x. What number will be inserted here? Possibly. So first of all, what I have to say, square root of function has to be greater or equal to 0. Then square both sides. The radical move to the power of x is greater or equal to 0. Obvious. That is always true. Any number insert in place of x here, it can't be negative. It can't, because exponential function to the power of x, if you are given, if you take positive number or negative number or 0, always the outcome is greater or equal to 0. So what is the domain here? The domain is a real number. Because x can be taken any number. It can't be negative, the outcome. Therefore, the domain must be the set of real number. But the process, remember, g of f of x. That means g of f of x. What's f of x? To the power of x. What is g of it? Square root of what is given to you here. Next. This one is somehow different. Every one of you need to focus here. Okay, here, what does it say? F of x is given. That is 5x plus 4. G of x is not given. That's what we are looking for. But the GOF is given already. Two functions, if composed, like f compose g, if it is linear, necessarily both must be linear. If f compose g is giving you quadratic, either both has to be. When you compose two functions, if the result quadratic, means either of the two has to be quadratic. Okay, so here two functions composed, and the result is what? Linear, as you see. This is a linear function, the composed one. So we need to think, this is something new that I'm telling you. Two functions after composition, if the result is linear, necessarily both linear. So GOF is linear. The GOF, G of f of x. This implies what? What does this imply? F must be linear and G also must be linear. As you see, F is already linear. What about G? G is not, we don't know. That's what we are looking for. That's not given to us, but necessarily G must be linear. So let, we can say, G of x be ax plus b. Mostly linear function will be represented by ax plus b. Let us take this as G. Okay, since G of x is a linear function, we can represent it by ax plus b or any variable. You can say bx plus c or cx plus d, whatever. Now let's get back to the given one. What's the given? G of GOF x is given to us 7x minus 1. That means G of f of x, which is G of, what is f of x? 5x plus 4. 5x plus 4. And what is G of 5x plus 4? First of all, G of x, ax plus b. So when you say G of this thing, I will replace in place of x here. So the result will be a in bracket 5x plus 4 plus b, which is equal to, the composition is already 7x minus 1. This is a 7x minus 1 already. Then multiply. When you multiply, a times this one, 5ax plus 4a plus b is equal to 7x minus 1. Then take the coefficient of x. What is the coefficient of x here to the left side? 5a. 5a, it must be equal to the coefficient of x to the right side. That is 7. Okay, these two are equal. They are equal. Both of them are linear. That means the coefficient of x to the left side, it must be the coefficient of x to the right side. Then divide by 5 both sides. This implies that a is equal to 7 over 5. We got the value of a. And again, to get the b, the constant term. What's the constant term here? For a plus b. For a plus b, it must be equal to the constant term to the right side, which is negative 1. But we know the value of a, that is 7 over 5. So 4 times 7 over 5 plus b is equal to negative 5. Then multiply 28 over 5 plus b is equal to negative 1. Okay. Okay, let's continue it here. 28 over 5 plus b is equal to negative 1. Then the b value will be, you need to remove this one, negative 1 minus 28 over 5. So b value will be negative 5 minus 28 will be negative 33 over 5. This is the value of b. Therefore, what will, now remember, the a value 7 over 5, got it in the b. So we said already g of x is equal to what? Ax plus b. That's what we are looking for. So g of x will be now, we know the a, which is 7 over 5, x minus 33 over 5. That's going to be the value of g. So that's going to be the way how to do. We will do additional questions by using the exercise 1.10. Exercise 1.10 is around 10 questions are there. So try them all. I can't select, try them all. Then when you have difficulty, we'll discuss. Next time when I come, I'm not going to give you all correction, but selectively I'll try to give you some corrections. But for today, that's going to be end of our lesson. Thank you for watching.